What up, everybody? Welcome to another episode of Let's Ask Paul, the podcast where I, Paul Abernathy, do my best to answer all your pressing electrical code related questions so that you get your questions answered. And you can do that by sending your question in to us through the portal over at paulabernathy.com. It's a very simple platform. You simply go there, fill in the information, ask your question, click the submit button. In fact, even on that portal, you can actually listen to episodes of the Let's Ask Paul. In case you don't want to listen to all of our podcasts, the mobile stuff and all this, you just want to do the Let's Ask Paul, then that's an easy way to listen. But if you're listening by any of your popular listening platforms, you want to make sure that you check them out. And all you got to do is go over to any of your popular platforms and search for Master the NEC, whether it's Spreaker, Spotify, Apple Podcasts, Google Podcasts, Deezer, iHeartRadio, whatever your most popular podcast listening platform, just simply search for Master the NEC and make sure you subscribe to that, and you will get access to all of our podcasts. And we have hundreds of them. So make sure you check that out. And I don't index them very well, so you got to kind of go through and listen. And I encourage you to go back to some of the older stuff. I mean, you could listen to our podcasts for an entire year and never listen to the same podcast twice. That's how many podcasts we have. So I encourage you to go back and listen. We cover all different types of topics, and you just got to go back and listen. And I don't index them very well, so you just got to go back and listen, okay? All right, so welcome to the show today. Today, if you're looking for an electrical education, anything to learn the NEC, if you're pre-licensed and you're studying for your exam, then you want to get our Fast Tracks Black or Fast Tracks Plus. The only difference in the two is the Plus just gives you access to our annual membership for a discounted price. That's the only difference. The Fast Tracks Black is our core program that teaches you the NEC. So that's what you'd get if you want to learn the code, or if you're preparing for an exam, you always want to go towards that program. And then you get to decide whether or not you want access to the videos or not. It's no different than our annual membership. Instead of paying $125, you get it for $100. So basically, it's a discount package deal. If you already have a license and you want to deep dive and really start learning everything, or if you're a company and you have a bunch of employees and you want to keep them all on the same page, then we have residential, which is our Fast Tracks Red. We have our commercial wiring code, which is the Fast Tracks Green. We have the blue for industrial. We have the purple, which is grounding and bonding. Everybody needs to have a deeper understanding of grounding and bonding, that's for sure. And we have what's called the yellow. And the yellow is your basic electrical theory. So if you're trying to get Electricity 101 and all those theory things, that's the one that you do there. And of course, we have the bundles. Now, the bundles gives you up to 4 courses of our courses that you can select, okay? So it includes the black, the red, the green, and the blue, but you can substitute one of those for the purple or the yellow if you want, okay? We'll allow you that flexibility. Just when you order it, make sure in the comments you tell us which one you want to substitute. And that's the best value out there, by the way, okay? Because you basically, you get access to all of our main core courses. And the other big thing is you get access to it for, rather than a year, you get 2 years. That's huge, okay? And you get to move in and out of any of those courses you want. Okay. So anyway, that's the orange. That's the bundle. If you're interested in that, check out our website, fasttracksystem.com or electricalcodeacademy.com.net.org, whatever floats your boat. We'll have a link in the description to either one, and you do whatever one you want. They're both the same website. In other words, they're the same company. So don't let that confuse you. All right. So today's episode, I had somebody ask me, Paul, can you go over briefly? And of course, most people know I can't do anything, quote, briefly, okay? But I will do my best to try to go over the high points of doing this question. And so I'll do my best. Now, I will tell you that I have an extensive select collection of videos that talk about sizing for one-family dwellings or single-family dwellings. So I encourage you to go search for that. If you're our annual subscriber or you're one of our Plus members, there is videos on that. If you're in our Fast Tracks Black, we covered that extensively anyway. And of course, you all know that you have access to me on Wednesday nights if you're a Fast Tracks member. It doesn't matter which course you're in. If you're just a Fast Tracks member, then you have access to me on the Wednesday nights. So we typically will answer questions from anything. If you have a question in one of your courses, we'll go look at that. If you're in a residential program and you come in and you want to talk about something in that, we'll go look at it. So that's the beautiful thing about Wednesday nights. You get access to me, and I'm here for you. I'm here to help you and answer any question you might have. So it's, again, basically you're getting a consultant every week, and I'm usually there for a couple hours. So we cover a lot of stuff. So join us if you're a Fast Tracks member. Okay. So today's question was, Paul, can you go over the standard method for a one-family dwelling and give me the highlights? I'm studying for my electrical exam, and the last time I took the exam, I failed, and there was a lot of questions on there about single-family dwelling calculations. Can you help? Thanks in advance. Okay. I most certainly can help you. And the reason that you see a lot of the one family dwelling and the standard method stuff is because that's typically low hanging fruit, if you will, on an exam. They want to make sure that you know how to do the different steps. They're not going to ask you to calculate the entire dwelling, right? With the exceptions of some states who are starting to do what we call bulk questions now, where they'll give you a scenario. And we do this in our Fast Tracks, by the way, where we'll give you an example of a dwelling, and then we'll ask you a bunch of questions about it. So essentially, you're going to be doing the whole calculation. But each one of the questions, it might have 10 questions based on that general, 10 questions that you have to answer based on a general example that's given. That's becoming very popular to do that. And so that's kind of how our course is designed. So if you're interested in our Fast Tracks program, it's so much different than studying on your own. Because there's no way that you can stay dedicated and follow a structured plan on your own. You're just going to be all over the place. I don't know how many emails I get weekly where I failed my exam by this point or 2 points or 3 points. No, you failed it by way more than 1 or 2 points if you look at the realm of perfection, right? So our course is designed to give you the confidence, but I want you to take something away from it. I mean, I want you to remember some of this stuff. Okay, it's not just about getting your license. I mean, this is about becoming better in the field. And that's what I'm all about, because I'm here to raise out excellence. I'm not here to just help you squeak by. But you know what? I can't control what you purchase stuff for. So again, you do you, but that's my mentality. I'm always trying to educate and make you a better electrician. That's my goal. Okay. All right. So back to the question. So assuming you got your code book, and we're going to use the 2020, even though usually by now I'm going to start switching into the 2023. But since I do recognize that the majority of the exams out there in the country are going to be on the 2020, the majority, there's some of them are still on the 2017. I get it, you know. I know. I wish the states would move forward and speed up. And why there's so much bureaucracy involved in this garbage, I don't know. I really don't. But at the end of the day, you're going to see more and more going to the 2023 in the next 6 to 8 months. But the 2020 is going to be around much longer. And those at least from the 17 are going to start jumping up to the 2020. So that's why we're going to focus on the lion's share, and that'd be the 2020 code. Okay. So this information also, by the way, is covered extensively in our Fast Tracks Black program. So again, we're not reinventing the wheel for those that are in that program. If you're listening, we're just going to re-qualify what you should know already. All right. So the standard method, a couple things that we want to throw out there to you, and I'm going to go step by step through things that you have to consider, and I'm going to give you code references. So if you've got a pen handy, you can write these down if you want, but it's a multi-step process that we're going to be following, okay? All right, now the first thing that you want to remember, and we're not necessarily going to do any calculation here because it's very hard to visualize that, even paint that mental picture when you're listening to a podcast. So I'm just going to give you references and we're going to talk about it. We're going to have a little conversation, if you will, okay? So the first thing I want to consider when I'm doing a load calculation for dwelling is I need to get the dimensions here. I need to know what are the outside dimensions of this structure. Now, if it's a 2-story building, then I need to take into account 2 floors. If it's a dwelling with an unfinished basement, then that is adaptable for future use. So I'm obviously want to take in that square footage as well. So I've got multiple floors. So I want to take in those as consideration when I'm doing the calculation, right? So all of that instructions are given to us. And if you're in the 2020 code, what I want you to do is I want you to go to 220.14J. Okay, that's where I want you to be. All right, once you're at 220.14J, let's read it real quick. It says dwelling units. Well, that's what we're doing, right? One family dwelling. It's a dwelling unit. So it says in a one family, two family, and multifamily dwelling, the minimum unit load shall be not less than 33 amperes, and that is meters squared. And it says 3 volt amperes per square foot. Now, we're always going to focus on the square foot. Don't forget about the others, but we're going to focus on square foot, okay? All right, so 3 VA per square foot. Now, in the 2017 code, you got that from table 220.12, but we've changed, okay? We've moved on to that, and we've moved that information into J now, so it's 3 VA. Now, here's what's important about that. For one family dwelling, it's 3 VA per square foot, but even the individual dwelling units in a multifamily building, which we cover in our course in Unit 11, we get very deep into that, it's still 3 VA per square foot, okay? All right, so just wanted to make sure that you understand. 3 VA per square foot. Now, in the 2020 code, it proceeds to tell us that. Now, when I told you earlier about the dimensions, where do we get the dimensions? Where do we get the floor area? Where are we pulling that information from? Well, the instructions come in 220.11. Now, if you go look at 220.11, which used to be in 220.12, but it's 220.11 in the 2020, it says the floor area for each floor now, if you got more than one floor, like a basement and a first floor, each floor, it says, shall be calculated from the outside dimensions of the building. Okay, dwelling unit or other areas involved. For dwelling units, the calculated floor area shall not include open porches, garages, or unused or unfinished spaces that are not adaptable for future use. Well, obviously, an unfinished basement is adaptable for future use. Okay, an attic with a pull-down set of stairs is not adaptable for future use. Yeah, you can get into semantics and say, yeah, Paul, well, we could come in and change the trusses and stop. Don't just stop. Okay, don't go there. Don't be that guy. Okay, it's either adaptable for future use or it's not. If you're preparing for an exam, it's going to be very clear on the exam. Okay, I'm not required to be Nostradamus here when I'm doing this. If it's adaptable for future use, it should be pretty evident. Now, if I had an attic that had fixed stairs going up to it, okay, and it could support the weight, it just was unfinished, but it could be finished off, then it's adaptable for future use, okay? If it meets the building code, it's a certain number of square feet, the ceilings are the right height, everything makes it something that can be adaptable for future use, then I want to count that square footage. But if it's not adaptable for future use, then I don't, okay? And so this is telling me garages don't have to be taken into consideration. Open porches, I can subtract that from your square footage. And again, any unused or unfinished spaces that aren't adaptable for future use, I can take those off as well. Now, an unfinished basement is adaptable, so you want to make sure that you add that square footage into your calculation based on the outside dimensions, okay? So if you got 2 floors, a 3-floor home, every floor counts, okay? And so it's 3 VA per square foot. So for your general lighting, in general use type of receptacle loads, 220.14J, that's where you're going to do the 3 VA times the square footage using the outside dimensions, okay? So that's where you're going to get that 3 VA per square foot from, okay? So not that we're going to do any calculations here, but if I had a 2-story building and it was 1,000 square foot for each floor, right? Then that'd be 1,000 plus 1,000, that's 2,000. 2,000 times 3 is 6,000 square foot. So that is my base value for the general lighting and receptacle loads, okay? Now, a lot of times with this, people will get confused and they'll go, well, what do you mean general use receptacles? I mean the receptacles that you would put in your bedroom, your living room, okay? The basement, when you're thinking about the unfinished basement that's going to ultimately be finished, these are general use receptacles, okay? We're not talking about the small appliance that are on the counter in the kitchen. We're not talking about that. That's got its own provisions, and we're going to get there. That's not what we're talking about. We're talking about general provisions. Also, if you read 220.14J, you'll see that there's a 1, a 2, and a 3. The general lighting that's in this dwelling is also covered by that 3 VA per square foot. It's already in there. Okay? So your general use receptacles are in there. Your general lighting outlets are in there. All that general stuff is already part of that 3 VA per square foot. Okay? Don't have to do anything extra. Okay? All right, so you would write that down typically. Now, the next thing you'd have to look at is say, okay, logically, what's the next step, Paul? I get it. I've got my general lighting and general receptacle use. I followed 220.14J. I feel good about it. What's next? Well, you got to do the small appliance brand circuits. Now, the small appliance brand circuits are going to be something that's covered in 210.11C1. That's going to tell you that you have to have at least C1. It's got to have at least 2. Okay, at least 2 small appliance brand circuits. They have to serve the countertop. Okay, and so it's also going to cover the receptacles that are in the kitchen, in a pantry, in a dining room. Now, I can always have more than 2, but I got to have at least 2. So on an exam, for example, if they don't tell you the number and they want you to do a load calculation on a one-family dwelling, then you have to assume at least 2. Okay. In the real world, if you have more than 2, you have to account for those. If you have multiple small appliance brand circuits, then you have to take them into consideration. Now, you're probably saying, okay, well, what is the VA value that we're going to use? And so that's when you're going to look at 220.52A. And remember, when we're talking 220, we're looking for values as part of a calculation. When we're looking at 210.11, which is to determine the number of small appliance brand circuits, that's just the number of brand circuits. That's a number, okay? But we need to get a VA value, okay, volt ampere. And so that's 220.52A. So if you look at 220.52A, here's what it says. It says small appliance load circuit. It says in each dwelling unit, the load shall be calculated at 1500 VA for each 2-wire small appliance brand circuit as covered in 210.11C1. Okay, that's the one that tells you got to have at least 2. Okay. All right, and so that's the first part that we need to take into consideration. All right, so it's got to be at least 1500 VA, and there's 2 of them. So in our case, we didn't say how many, so we're going to go with the minimum. The minimum is at least 2, so it's 1500 VA times 2. And you would write that down. Okay, in this case, 3,000. That's your VA for the 2 minimum small appliances. Then the next thing you're going to look at is your laundry circuit. Again, we're talking one-family dwellings. So you got to have a laundry circuit. Now, that does not mean you have to have a dryer. Okay, that has a separate rules in 220.54 that we're going to look at. You got to at least have a laundry circuit. And that's going to be at least one 20 amp circuit. And that's covered in 210.11C2. That talks about the circuit. But the VA value that you're going to use for this calculation, that's covered in 220.52B. And that's pretty much the same as your small appliance brand circuit. It's 1500 VA shall be included for each 2-wire branch circuit installed as covered in 210.11C2. Now remember, 210.11C2 only requires 1, at least 1. In the real world, if you've got more than 1, then you need to take that into consideration. It would be 1500 VA for each one of those that you want to have or your customer wants to have. As far as an exam prep, if they don't tell you the number, then you at least have to have the minimum, and it's at least 1. So in our first calculation, this would be step 3 now. It's 1500 times 1 because I have to have at least 1, right? So you would add that to your equation. So now at this point, you're pretty much done with your general lighting, general use, your small appliance, and your laundry circuit requirements, okay? Those are required branch circuits that you have to have, okay? So the beautiful thing about this now is that you get to apply a demand factor, okay? Because of diversity that's involved, there's some the demand factors that you're going to be able to apply to this. And so that means you need to look at 220.42. Now, the reason that we're jumping now out of part 2 and jumping up into part 3 is because now we're going to start adding the pieces for our standard calculation. And that falls under part 3. If you look at part 3 of Article 220, it says feeder and service load calculations. I mean, that's what we're doing, right? What we did was we started with the pieces under part 2, and we're pulling those pieces. And where do we get the requirements to do that? Basically, it's 220.40. It tells you, it says the calculated load of the feeder or service shall not be less than the sum of the loads on the branch circuit supplied as determined in part 2 of this article. So we did that, right? We pulled the 220.14J. We pulled the circuits that were required in 210.11C1, which is back in branch circuits. We pulled all that information together, and now we're combining it all right? So if you go down and look at 220.42, before you even look at the table, just look at 220.42. Here's what it says. It says the demand factors specified in table 220.42 shall apply to that portion of the total branch circuit load calculated for general illumination. They shall not be applied in determining the number of branch circuits for general illumination. That's not what we're doing here. We're doing a load calc, okay? So we're not doing that in order to try to determine how many branch circuits we need, okay? We're doing a load calc. And so this gives us permission to apply this table. Now you're saying, but didn't it say general illumination? Why are we adding the receptacles? Because 220.14J told us that all of this load is to be incorporated in one usable value, okay? And that's what we're doing, okay? So we're allowed to apply all of these. So in case that ever gets confusing for you. Now, the second thing you're probably thinking is, well, yeah, but what about the small appliance in the laundry? Well, if you go look at 220.52A and B, you'll notice in the very last sentence, it tells you that these can be subject to the demands of table 220.42. So that's why we can lump them together and apply this table. Okay? Have you ever wondered how that works? Just go read the last sentence of 220.52A and B. And then, of course, you understand the rules of 220.14J. And so that's why we can apply 220.42. Make sense? Okay. So now we came up with that total value. And we took all the general lighting and receptacle loads at 3 VA per square foot. We took the minimum of 2 small appliances, and we took the minimum of at least 1 laundry. And we take those values and we add them up, and now we come over to this table. Now, this table is interesting because we're only going to focus with the top part, and that is dwelling units, right? And so here you see dwelling units, and it says the first 3,000 at 100%. So you're just taking at least 3,000 at its face value, at 3,000. And then it says from 3,001 to 120,000, or as I like to say, once you do the first 3,000, the next 117,000, because 117 plus 3,000 is 120. So since this second one goes up to 120, I like to say the next 117,000, you take it 35%, okay? So that's at 35. So you take the first 3,000 of whatever this adds up, this numbers from, again, the general lighting and receptacle loads at 3 VA per square foot, plus the minimum of 2 small appliance, and then the minimum of 1 laundry. You add that all up. You take 3,000 away from that and put it to the side, because that's 100%. Whatever is remaining above that, you multiply by 35%. And that value gets added back to the first 3,000, which was at 100%. Because that's what it is. 100% of 3,000 is 3,000, right? And then that's the value that you're going to use, and that completes the first step, okay? That's the first cumulative step that you have, okay? There's different parts to that, but that's how you calculate the general lighting and general use receptacle and small appliance and laundry calculation, okay? Now you move on to the next thing. You write that down. The next thing you're going to move on to, okay, is you're going to move to what's called fastened in place appliances. Okay, so it's the next logical step. And the fastened in place appliances are going to be under 220.53. And this is pretty straightforward. If you're in the 2020 code, it did add some clarity to it, but it's pretty straightforward. In a single family dwelling, what you're going to do is you're going to look for your appliances that are fastened in place. And here's what it says. It shall be permissible It's not required. It's a permissive rule. It shall be permissible to apply a demand factor of 75% to the nameplate rating load of 4 or more appliances rated a quarter horsepower or greater, or 500 watts or greater, that are fastened in place and that are served by the same feeder or service in the one family, two family, or multifamily dwelling. It says this demand factor shall not apply to household electric cooking equipment that are fastened in place, clothes dryers, space heating equipment, or air conditioning. The reason for that is because we already have rules that we're going to apply to those. So you don't want to double dip there. It only applies to those appliances that are fastened in place, and it only applies when they're greater, the 4th horsepower or greater, or 500 watts or greater, whatever the load is, and they're fastened in place, okay? And you have to have what? 4 or more. If you have less than 4, then you're just going to take them at the nameplate value, and we all know how you get VA from that, right? You take whatever the value is in amps on the nameplate, multiply it by the voltage, and that's going to give you your VA. And you're just going to add that as a contribution to your calculation, okay? Full value. But if we have 4 or more appliances, like maybe a garbage disposer, dishwasher, trash compactor, and maybe we have an attic fan or something like that, that would qualify as an appliance, then maybe if we have 4 or more, then we're going to get a 75% reduction, okay? But we get to apply 75%, I should say that. It's basically a 25% reduction, but we get to apply the 75% to that, okay? All right, so we do so, and that's pretty straightforward. We just take whatever the number is, and I also should remind you that a water heater, for example, is a fastened in place appliance, usually 4,500 watts, okay? So we're just going to take that and we'll, dishwasher, disposer. If we've got 4 or more, then we add them all up and then just multiply it by 75%. And that's the value that we would put. And that would be our next step. Just remember, if you don't have 4, if you have 3 or less, then you're just not going to apply any multiplier of 75%. You just take it at whatever the value is and you're just going to add them all up. And that's your contribution for that step. Just remember, the 75% can be used only when you're 4 or more fastened in place appliances. Okay? All right, we're done with that. You just add it to whatever the load was that you got from our first step that we did. So the next thing is the clothes dryers. Now, since we're doing a standard method, 220.54 says that you're going to use 5,000 watts, which is synonymous with VA in this example. So anytime you can start converting it over to VA, go on and start doing it. So a 5,000 watts or the nameplate, whichever is larger, in the standard method, that's how you do it. Now, in the optional method, you just take the nameplate. But we're not doing the optional. We're doing the standard. So if it was 5,500 watts clothes dryer, then I'm going to use 5,500. If it was a 4,500 watt clothes dryer, then I'm going to use 5,000. Right? So I'm simply going to punch that in, 5,000. You write it down. That's done. That step is done. Remember, we're doing single-family dwellings now. Don't start letting your mind wander to multifamily. We have a different video for that, different calculations involved with that, okay? All right, next is the household electric cooking appliances. Okay, so next is the cooking appliances, and as long as they're over 1 3/4 kW or 1,750 watts or VA, however, as long as they're over that, then you can use the allowances of 220.55, okay? Now, 220.55 is an interesting table, and you're basically going to use column C in all cases, unless your cooking equipment happens to fall under column A or B, okay? And you're going to always compare A and B to C, right, if note 3 is applicable. Now, what note 3 is, now that's the other thing. There's a bunch of notes underneath this table, 220.55. You need to get familiar with these notes. Now, we have videos out there that explain all of these notes, in exhaustive detail. So make sure you check that out and you watch those videos. Some of them exclusive, so you have to be our annual member or you're in the Fast Tracks program. And you'll see that there's different notes for different applications. But note 3 is specific because this is about cooking appliances that fall over 1 3/4, but don't exceed 8 3/4. So there's kind of this little window. And if they fall in that window, then you're allowed to use column A or B, depending on which one they fall under, in lieu of column C. Now, column C is a catch-all. Okay, everything gets compared to column C. But you get this permissive rule, it's called of in lieu of, which tends to confuse people, but it's saying, hey, look, I'll let you use column A or B depending on which one your cooking equipment falls under, but you're still going to compare it to C. And whichever one yields the best result, which is in this case the lowest result, you can use that. So that's what that means. But if note 3 doesn't apply, then you're going to stick with column C and follow those values. And then, again, if it's just 12 kW or less, you're just simply going to pull from the table. Okay. For example, if I had a 12 kW range in my calculation, I'm just going to use 8 kW because column C is actual demand values. And if you look under one appliance, it says 8 kW. So it doesn't matter in the standard method if that range, for example, says 12 kW. In my load calculation, I'm just going to use 8 kW. You with me? Okay. If that's confusing, dude, get into our Fast Tracks program because that means these are the kind of things that you really want to learn. And that's what our course does for you. It helps you get that knowledge. All right. So when it comes to the cooking, you're going to look at it and you're going to either use column C, or if it falls under B and C, then you can use those values and you have to compare those to column C, and you can take whichever is the lesser. Okay. Now, if you're over 12 kW for a range, for example, then that's when you're going to use note 1 or note 2, okay, for that application. And again, we're not going to go over that here because it's a visual thing, and I do have videos on that if you want that, okay, so you can look at that. But that's the next step. I need to come up with it. Now, if it's just a typical range in a typical 1 and 2 family dwelling, chances are it's just going to be 8 kW, and that's it. And that's what you would plug in here. Okay. And that's the next step. Now we're moving on to air conditioning and heating loads. Now, the interesting thing about this is it differs from the optional method, which you're just comparing AC to heat, and you take the whatever's the largest. Okay. In the 2017 code, that's exactly what you would do for AC versus heat, because those typically are what's called non-coincident loads. Means when one's on, the other one's not on. Now, the interesting thing about that is you could have something like a heat pump where the AC is running and the heat could be running. And then if that's the case, they're not non-coincident loads. And you just have to take their loads at their value and add them to the calculation. You don't get any break from that because they're not non-coincident loads. What's a non-coincident load? Well, a non-coincident load is 2 loads that will not be operating simultaneously. In other words, there's some type of interlock or there's some type of thermostatically controlled aspect that keeps one from operating while the other one's operating. So if I have a thermostat and it's set up, for example, that my heat cannot run when my AC is running, then that's an example of a non-coincident load. Now, in commercial buildings and industrial buildings, you still have this rule as well. So even though in dwellings we like to say heat versus AC, just remember that non-coincident loads could be multiple large motors in a building that might be interlocked so one motor can't be on while the other motor is running. And then you just simply would take whichever one of those motors is the largest motor, and that's how you would do it. When it comes to heat versus AC, what's interesting is that when you're doing the calculation and you're looking at 220.60, in the 2020 edition, it added a little step that you have to do that's not there in the 2017. So in the 2017, it's just easy. Do your AC loads, do your heat loads, compare the two, whichever's larger, that's the one you go with, then happy, you move on your way. In the 2020 code, it's not as easy when you look at the calculation. Now I'm going to read it to you because again, this can get complicated and I want to make it as simple as possible. 220.60, it's called non-coincident loads. It says where it is unlikely that 2 or more non-coincident loads will be in use simultaneously. Okay, it shall be permissible to use only the largest loads that would be used at one time for the calculation for calculating the total load of a feeder or service. Okay, so that's the first statement, and that's easy because that's the same as it's always been. If heat is greater, and typically heat will be because kWs and the amount of heating elements and whatnot, then if that's higher than the AC part, which you usually have the compressor, condensing fan, in the air handler. If you compare that to the heat, and it might be that you have heat strips in the air handler, so you need to also incorporate the air handler's values with that heat because it's going to blow that heat around, and you compare the two, right? Then, and obviously the air handler is not going to be a non-coincident load because it's going to be used whether or not it's blowing cool air or hot air, okay? So you have to add that to both of them when you're doing the comparison, right? Because it's going to be working for both of them for the most part. So whichever's larger, you typically go with whatever's the larger. Now, in the 2020, it goes on for another paragraph. It says, where a motor is part of the non-coincident load that is not the larger of the non-coincident loads, 125% of the motor load shall be used in calculating if it is the largest motor. Okay, so what does that mean for a single family dwelling? Okay. So the first step you should always do is if you have non-coincident loads, let's just say it's heat versus AC, compare the heat versus the AC. If the heat's larger than the AC, then so far the heat's the one you're going to use, right? Now you got to look at that AC. Most importantly, you got to look at that air conditioning compressor motor. Is that the largest other motor in your dwelling? And chances are it will be. And since it's the lesser of the two loads that you compared, that kicks in here to say, okay, you got to redo that calculation again. Now take that motor, which is probably the hermetic refrigerant motor, take that at 125%, okay, plus the sum of the air handler, plus the sum of the condensing fan, add them all together, and now compare that against the heat again. Now remember with the heat, you also had to add the air handler VA to that too, because again, it is going to blow that heat around. So when you're comparing them again, if the AC at this point doesn't overtake the heat and become the larger of the two because you added that additional 25% to that air compressor, if it doesn't overtake the heat at that point, then you still get to just throw the air conditioning part away and just use the heat for your calc. But by chance, if the AC now taking the air conditioning compressor at 125% plus the sum of the other motors that are associated, if that now all of a sudden overtakes the heat in the VA value, then guess what? You're now going to use the air conditioning load. Now I'm here to tell you, except for an exam where they set it up very uniquely designed to fail, usually the heat's going to be greater, right? But just, keep that in mind. That's how this works for the 2020 when you're doing that comparison, okay? It's just an exercise. Don't overthink it, okay? Do your first comparison and then determine whether or not the one that's the lesser happens to have the largest motor in the dwelling. If it does, do the calculation again. Take that largest motor at 125%, some of the other motors associated with it, and now compare it to the heat again. If it overtakes the heat, then you go with the AC. If it still doesn't overtake the heat, you keep the heat. That's all you're doing here, folks, okay? All right, pretty straightforward, right? All right, don't want to overthink it. Now, the last step that you need to do is you got to remember there's a little rule in here that is not as clean as people would like it to be, right? And that is 220.50 when it deals with motors. So you do have motors throughout your dwelling. You have a garbage disposer because it's given to you in horsepower, so that's a motor. Anything that gives you something in a horsepower rating, it's a motor. Or in 220.50, it flat out tells you that to look at 440.6 for hermetic refrigerant motor compressors, that's considered a motor, okay? Now, the 2023 tries to clarify this language a little bit and breaks these out and changes how 220.60 states the motors because they also want to make it clear that we're also talking about hermetic refrigerant motors and 440. We get it, but that's what it's doing. So if you look at 220.50, basically it's saying, okay, look for the largest motor in this dwelling, and I want you to take its value and I want you to multiply it by 25%. And you're saying, where does it say that? Well, it doesn't have to say that because it's basically referencing you to 430.24, right? And if you keep it simple, what does 430.24 tell us? You take the largest motor at 125% and the sum of the other motors in the group, right? Well, all of these motors are going to be in the same group because they're all connected to the same service. So they're all in the same group. So we've already taken the motors in this dwelling at 100%. Yeah, yes, we might have applied some demands to it, to appliances, certain things that have motors. But for the most part, we've already done the 100%, right? What we haven't done is captured that 25% for the largest motor. So that's all we're really doing. Don't overthink this. I know people would like this to say this a little bit better, but that's what it's saying. You just kind of gotta go with me on this. Been teaching for 32 years. This isn't something new. So what you're trying to do is find the largest motor, and you're just going to multiply it by 25%. And then take that value, and that's what you add to your calculation. Now, here's something interesting. If you were comparing heat versus AC in the previous step that we did, and the AC overtook the heat because you used that 125% for the air conditioning compressor, right? And that was what overtook the heat, then guess what? That 25% for the largest motor has already been taken care of. So you've already satisfied 220.50, so you don't have to go searching for the largest motor at that point, right? However, if the heat still beat the AC in the previous step and we discounted the AC, now that's gone. So now you've got to go searching for the largest other motor in the dwelling. And that might be the trash compactor, right? And so you're going to take that value and you're going to take that times 25%. And all we're trying to do is capture that additional 25%. That's all we're trying to do. Find the largest motor. Now, we're not doing that for all the motors. Just the first motor, just like what it says in 430.24. We only need to do this for one. I can tell you this blows people's minds because when we do multifamily dwellings and there's like 10-story building with 10 units and we go looking for the largest motor, folks want to do this for every floor. So they're like, well, I got 10 units, Paul. I got to take every one of them at 125%. No, just the largest one. That's it. Just one. Not all 10, just one. Okay? People overcomplicate this thing really badly. Okay? So anyway, that's all it's asking us to do. And it's no different than what we do for motors, right? I could have a big commercial building with 10 motors in it. I find the largest one at 125%, and it's the sum, the FLC of all the other motors. So I'm only taking one of them at 125%. And that's what it tells us in 430.24. We're not doing anything different with a dwelling unit. It's the same thing. Okay? But people kind of get locked into that and say, well, are you sure? Are you sure? Yes, I'm 100% sure. All right. Okay. So once we got all that, all we're doing now is adding up all those steps. We come up with our calculation that we did for our general lighting, general use receptacles, small appliance and laundry, where we applied 220.42. We take that value. We take the value from all our fasten in place appliances that are rated a quarter horsepower or 500 watts or greater. If we applied the 75%, that's great. If we didn't, then we taken it full value. We did the clothes dryers. We did the cooking. We had the heat versus AC in our case for the single family dwelling. And then we found the largest motor and we did it at 25%. We add all that up. Once we add all that up, we're simply going to divide that by the voltage from the supply. And that is probably 120/240. Okay. And so we simply take whatever the total VA is, divide it by 240, and that's going to give us our minimum ampacity. And that's what we're going to be searching for conductors for. And we're going to go to 31016, and we're going to try to find what size conductor we would use. Okay? Now, interesting. Once we do that, then we have to determine what's the minimum size of the service that we're dealing with here. So if those conductors came back at, I just throw you a number out there, at 193 amps, and I had to have conductors for good for 193 amps. Well, before we even start looking for conductors, and I'm going to show you what we might be able to do in 310.12, the first thing you're thinking, okay, I get it, but I have to size the protection first. Because once I establish the protection, okay, then I can use what we call the 83% rule if it's applicable. But I still have to do it. So I did my load calc. It was 193 amps. I'm just using numbers here. So then I say, okay, what is the size of this service if I have a calculated load now in amps of 193. All right, so you're going to go to 240.6a, and you're going to look at your options. And I'm going to look at, these are standard size overcurrent protection, okay? And I'm looking, and I'm seeing, okay, I don't have anything for 193, but I have something for 200, okay? So I'm going to be able to install it on 200 as long as we don't exceed 800 amps, okay? And we're following all the rules in 240.4. We're good to go. And so I'm going to put it on it. It's going to be minimum size is 200 amperes, okay? Now remember, the conductors, if we didn't use the 83% rule, and I'll explain that in a minute, we'd have to have conductors that are at least good for 193 amps. So we would go to table 31016, okay? And remember, I didn't give you any adjustment or corrections. We're just talking amps. I'm going to be in the 75-degree column, and we're going to assume copper unless stated otherwise. And the reason we're going to be in the 75-degree column is because of the terminal limitations in 110.14c1. And that means that it is over 100 amps, so it's going to be under the 75. Okay? So we're going to go to 75, and it looks like in order to get to 193, we're going to be at 3 aught. Okay? Or as some people say, 3 naught. Okay? That's good for 200 amperes. Right? So we would have a 200 amp overcurrent device, and we would have a 3 aught copper. And if we were doing aluminum under the 75, it looks like we would have to have a 250 KC mil aluminum. Okay, it's good for 205 amps. Okay, makes sense? Everything seems good here? Okay, now that's what you would do if you don't get to apply the rules of 310.12. And you might be thinking, okay, Paul, the hell are you talking about 310.12? Because if you're in the 2017 code, you're not going to see 310.12. It's 310.15B7. But in your 2020, it is 310.12. Now, 310.12 is purely talking about the conductor sizing, okay? And we have an allowance here. And it is called, for lack of a better, what we've called it is the 83% rule. So the service conductors or feeder conductors, where applicable, cannot be less than 83% of the service rating. Now, in our case, the service rating was 200 amps. That's what we picked in 240.6a, right? So the minimum size service conductors that we could have for our application utilizing 310.12, and you got to read it, because in order to be able to use this, the service rating has to be between 100 and 400 amps, and ours it's 200, so it falls in that window. And the conductors that we're talking about are seeing 100% of the load, right? Means that we don't have a meter feeding a panel outside with a couple breakers in it, and then going from the load side of that inside feeding another panel, so that the conductors from that outside panel to the inside panel are not seeing 100% of the load. You with me? Or even if we had a service disconnecting means outside, okay, and everything on the load side of that would be a feeder, let's say, it's still seeing 100% of the load because all that is a disconnect outside. This can get confusing for people. So let me make it simple. As long as the conductors in question are seeing 100% of the load that can be applied, then you can apply these rules. Now, without a visual, I do have a video on this. It's called Derating Demystified. It's another video that's part of our exclusive annual membership that I encourage you to get. It shows your patronage for our company and maybe appreciative of these podcasts and videos. Buy an annual membership. It's $125. You get access to it. Okay? All right. So assuming we're able to apply 310.12a, we meet all these rules. Basically, it's weatherhead coming down, go through the meter. It's outside hitting a service disconnect outside that meets the requirements of 230.95. Everything's good. Is it 95 or 85? I think it's 230.85. Hold on. Having a brain fart. But that's the beautiful thing. I can go back and look. Maybe it's 85. Let's go look. Yes, it's 85. I'm sorry. 230.85. That's emergency disconnect. It's meeting all that. The option we're using is it is a service disconnect outside. So we're marking it as emergency disconnect and service disconnect. Bada boom, bada bang. And so we're sizing the conductors from the weatherhead down through the meter to the line side or supply side of the service disconnecting means. Okay. So we're going to be utilizing 310.12a. And so those conductors are seeing 100% of the load. Okay. So we get to apply this. So now remember, it was a 200 amp rated service. So I go 200 times 0.83, and that is 166. Now, once I know it's 166, I can now go to table 310.16, still under the 75-degree column. I can come down and find me a conductor that can handle 166 amps, okay? Because that's the minimum. It's got to at least be that. So it looks like now we could actually go with a 2-aught instead of a 3-aught. A 2-aught's good for 175. So easily it's going to be at least 83% in sizing, okay, of the service rating. Makes sense? All right. And for aluminum, same concept. It looks like at that point, we can get a 4-aught. And that is why you see SE cable 4-aught being the most commonly used for 200 amp service, because they figured that into it. It's all kind of taking care of itself. Okay. All right. Without getting too deep with that, let's kind of go back now. Now, if you're at 310.12, you could say, well, Paul, screw all that. I'll just go to the new table. So the table has been added at the bottom of 310.12. This table used to be in the back in Informative Annex D, I believe D7. So it used to be back there, and it's now been moved into the code body. Remember now, this table is only applicable if there is no adjustment or corrections to take place. If there's an ambient temperature other than 30 degrees Celsius, 86 degrees Fahrenheit, or by some weird chance, it's a rarity, but some weird chance you have more than 3 current carrying conductors, then this table is useless. You have to do the same kind of calculation using 310.16 that we always do, applying adjustment and corrections and yada, yada, yada. And then your conductor, then you still can use the 83%. It just, the conductor can't be smaller than 83% of whatever the service or feeder rating is. So you still can meet the 83%. It's just you're not going to be able to use this table to just kind of shortcut. But in our case, we didn't have any of those things, so you could have just gone right to the table. But I think it's important that you know how to do the calculation. So if you come down and look at the table for 200 amps, you go to the right, you'll see copper 2-aught and aluminum 4-aught. And we kind of did the math without having to use this table. And as I tell students all the time, get used to doing the math and get away from just going to this table. Get used to it, okay? If it helps you out any, all right? Okay, so anyway, that's what we're talking about here in the ability to use 310.12. Now, the other question that people will ask me from time to time is, when do I use 310.12? On an exam or even in the real world, any time that your parameters fall within the use of 310.12, you're going to use it. You definitely want to use it. So if your service is 100 or 400 amps, then you want to use 310.12. Now here's interesting. It doesn't matter whether it's a optional method or even the standard method. 310.12 isn't dedicated to either one of those. The threshold is it has to be between 100 and 400 amps. Of course, with an optional method, it has to be at least 100 amps anyway. So you can apply 310.12 to either the standard or the optional method. Don't get lost in that. Don't think this is a standard only thing. It's not. Okay? So, anywho, that's about the best that I can do with that and kind of give you the idea. Those are the steps. Now, to finish this thing out, the neutral calculation. How do you do the neutral? Well, the neutral is exactly the same as the way we just did the standard method. Every circuit that has a neutral contribution has to be taken into consideration. So the first step that you did, where you took 3 VA per square foot, the 2 small appliance branch circuits, the laundry, all of those, the 1500 VA for each one of the small appliance and laundries, that's still going to apply to the neutral. You still get to apply 220.42 and all the demand factors. So once you've already done the calculation for the standard, you can still use all that same information in step 1 or that first part for the neutral. All still applicable. Now, where it starts to get different is now when you're moving into the appliances. The appliances, it's the same thing. You still get to apply the 75% if you have 4 or more of the appliances, but you don't use the loads that are 240 volt, only the loads that incorporate a neutral conductor. So for example, you wouldn't use a water heater, but if the dishwasher, the disposer, the trash compactor, and all that are 120 volt loads, then you're going to contribute those to the neutral. Now remember, you're not going to apply the 75% if you have 3 or less. Okay, you're just going to take the full value. Okay. When it comes to the clothes dryer in the cooking, you take the value that you got from your first calculation that you did for the standard, and you just multiply that by 70%. And that's the value you're going to use for your neutral. Now, if you're wondering, where do I get that, Paul? Where does it say take that value that I just calculated for the size of my clothes dryer, which is that 5,000 VA, you remember? You just simply take that and multiply that by 70%. Where do I get that? Well, that's in 220.61b. And in 220.61b tells me that I can take an additional demand, right? And that additional demand is that 70%, right? So I take whatever the VA is based on my ungrounded hot conductor calculation, and I simply multiply that by 70%, and that's the part that I take for my neutral contribution. And that's the same thing for the cooking appliance. Let's say if it was a 12 kW range, electric range, and we know that 220.55 says that I'm just going to go with 8 kW because it's one appliance and it's not over 12. So I can use the demand values in column C. So it's 8. Don't get lost that it's still a 12. We're allowed to use 8 for this. So I take that 8,000 and I multiply that point by 0.70, and that's 5,600. That is my neutral contribution, right? You remember dryers and ranges, you run 4 conductors. It needs a neutral, okay? Water heaters don't need a neutral, pure 240, okay? Okay. Then you get down to the air conditioning and versus heat. Obviously, the heat's probably going to be 240, so you don't add that. But you have an air handler. That's probably going to be 120. You might have an air conditioning condenser fan. If that's 120, you're going to take that value, okay? Not the compressor, because that's 240. You get me? You're only going to take the loads that are 120 volt loads and add them to the neutrals, okay? So you're going to add that, okay, for your AC and heat, which basically is not going to be the heat. You take all the loads that are 120 volt or 115 volt loads and you add that. Then the largest motor, you still have to do that. But you're only going to take the largest motor that's a 120 volt motor, right? Or 115, depending on how they give it to you on the exam, okay? Then that's what you're going to use. Now, here's a good tip for you. If they give you a motor or they give you something at 115 and your mind's thinking, yeah, but it's really 120, no. Use what they give you. If they give you it as 115, use it as 115, okay, when it comes to the voltage, okay? Don't overthink it. And so you're searching for the largest motor that's a 120 volt motor or 115 volt motor, one that's got a neutral load. And you just take that largest one and you multiply that by 25%, because again, all we're trying to capture is that 25%. That's it. And then you add them all up like you did before, divided by the 240, which is your system voltage, and that's going to give you a minimum ampacity. And so when you got the minimum ampacity, at that point, you got to size the neutral. Now, a lot of times when it comes to the neutrals, people get lost in this because, again, you got to size a neutral to handle the maximum imbalance load, and that's basically what you've done. You've just done the calculation, okay? But when we start this journey, I usually like to take people back to the root of sizing, and that takes us back to 250.24. And if you go back to 250.24 and you look at it, what is it talking about? 250.24 says grounding of systems supplied alternating current systems. And you have an A, a B, an A and blah, blah, blah. Then you have a B, blah, blah, blah. And then you get all the way down and you get to C. And in C, it's got a C1 and a C2, right? So this is talking about the grounded conductor brought to the service. And it ends up telling you it shall be installed in accordance with C1 through C4. Now, C1 is for sizing a single raceway or cable. It says the grounded conductors shall not be smaller than specified in table 250.102C1. Now, I'm going to tell you right now, usually sizing it to the maximum imbalance load due to a calculation we just did is going to probably yield the size of conductor you need, because then you would just go over to 310/16 and pick your conductor that can handle that current. Okay, pretty straightforward, right? Okay, but there is occasion where you do want to check it against 250.102 to make sure that it's at least that size. And so you'll go look and you'll see that, okay, if we did one that was the 2-aught copper for the hot conductors, then we come over here and you see that under copper 2-aught, and then it says the grounded conductor has to be at least a 4 gauge. Okay. Well, if that 4 gauge is larger than what the size is for your calculated load that we just did, then it can't be less than a 4. Chances are the load calc that you did is going to probably be larger than 4 anyway. So this is just, it can't be smaller than a 4, but it most certainly could be larger than a 4. Okay. Make sense? Okay. Just wanted to make sure I clarified with the sizing requirements for that. And of course, lastly, if you're sizing your grounding electrode conductor at this point to your electrode, whatever your electrode is, then you're going to be looking at 250.66. You're going to go to the table if you don't know what the electrode is. If they tell you it's a ground rod and it's a sole connection, that type of concept where it goes from the service down to the ground rod and that's it, then you're going to go to 250.66A. If it's concrete and case electrode, does the same thing. You're going to go to 250.66B, and C would be ground ring. If they don't state the type of electrode, then you're just going to go to table 250.66 in general, and it's based on the size of the service conductors. Okay? Pretty straightforward on all of that information. None of that's overly confusing at any part. The neat thing about our program is that we do give you these sheets, and these sheets will walk you through each step of the calculation so that it ingrains it in your mind. And that's what we're trying to do. We're trying to ingrain it in your mind so that you understand each one of these little elements. And that's what we tried to do here. And I've kind of given you the overview. But if you want more information on this, then I encourage you to get in our Fast Tracks program. We go into this detailed. We have a unit 8, 11, and 13 that will test your mental toughness. I'm telling you right now, if you really look at those and you don't cheat, okay, because we do have some videos out there on these, but if you don't cheat and you really focus on it and don't worry about your low score, because that should tell you something. You don't understand the steps. In our competency review, we're going to test you on each one of these aspects, and you're going to see whether or not you're proficient in it or not. And that's what it's all about. This is learning. Okay, my grades don't matter. The exam and in the real world's what matters. And that's what our courses are designed to help with. So if you're into that, do me a favor. Go check out our Fast Tracks. Watch our demo video. If you got any questions, holler at us. Let us know. Go to the Sparky Hub. Just go to www.thesparkyhub.com. Get a free account and post your question if you got any questions. We have a chat. Go to fasttrackschat.com. You can ask questions there if you want. Make sure you check back, because if nobody's in the room, you got to come back to get the answer later. So bookmark it. But there's so many ways that we can get you the answers. If you have any questions about anything that we offer, we're here to help you. I'm not here just to sell you a book. I'm not here to abandon you. I'm here to teach you the National Electrical Code. All right, folks, till next time, stay safe, God bless, and hope you got something out of the episode. This is an awful lot to absorb in a little over an hour. So again, hopefully you got something out of it. Till next time, stay safe, God bless.